last video I was discussing some important points regarding vectors. In that, the third point was that the angle between two vectors is angle between the two vectors is smaller of the two angles matches tail by tail. What does it mean? So if I explain it, so there will be two vectors, let's say vector A and vector B. Okay, now I have to find the angle between them. So what would be the possibilities? So as you know, the parallel shifting of any vectors will not change the vectors. So I can bring these vectors by matching the tail of this and the equal vectors. Means this vector, if it is B, it is represented by this arrow. The magnitude I will keep same, and I will match the tail of the vector A. I will match the tail of this. Parallelly I will shift it, and the direction also I will keep same. So when it is matching tail to tail of this, the angle, there will be two angle will form this angle, the interior angle, and the other angle is exterior angle. So it says the angle between two vectors, is vector A and vector B are two vectors, is the smallest of the two angles. So out of this 1 and 2 angle, the smallest one is this one. So we'll always consider the angle which is smaller when the two vectors bring by matching the tail to tail. So that means this is the condition when the angle forms between this will be the angle. We'll consider the angle between the vector which is the smallest one. And as per the understanding, this angle, let's say this is denoted by theta. So theta is always in between 0 to 180 degree. It cannot be ever more than 180 degree or less than 0. It is always between lying this condition. So this is very important point to be remembered and to understood. So if you say like that, so then other condition may arise that this is one vector, this is another vector, this is A and this is B. In this condition, what would be the angle between that? So as you see, this is tail, this is head, this is tail and head of vector A, and this is tail and head of the vector B. So if it is this condition, so and if you are told to calculate the angle between that, then you have to shift this vector or shift this vector parallelly to the vector itself, so that tail can be matched each other. So to match this vector's tail, we have to move it forward equally. Okay, and this magnitude I will keep same, and I will move linearly in the same direction. Okay, now this is the condition when the magnitude kept same and the vector is parallelly shift. This also is called the parallel shift. When it is linearly shifted, then also it can be told as a parallel shift. So then also that vector will not change this value. So now it is as because, so the angle formed is this one is the angle which is called the angle between the vectors. This is not the angle which will say the angle between the vectors, or neither this angle is said to be the angle between the vectors, or neither this angle is said to be the angle between the vectors. All which angles are not considered to be. Only thing is this angle is said to be the angle between two vectors. Okay. So there are two things: the angle between the vectors and the vector angle. The angle between two vectors, which is the angle between the vectors in smaller value, and the vector angle, which is the angle with positive x-axis the in anti-clockwise direction. So these two things should not be confused. If say there is two vectors, then the angle between the vectors is to be this angle, and the vector angle with positive x-axis for vector A is this one, and for B is this one, anti-clockwise. So this is the difference between these two terms. So now there are one more point which is important, but it is to be understood. Is not so important, but it is to be understood. No scalar can be added to a vector. That means if I say a scalar have numerical value and unit, so 2 kg of it denotes the mass of that, cannot be added to 3 kilonewton or let's say 2 kilonewton east of any vector or Newton, not only 2 Newton east. There is this is a force. So the mass and force, or this is scalar, this is vector, cannot be added together because vectors follow the vector law of addition, and scalar follows algebraic laws. Algebraic law of addition. So these are two different things that cannot be summed up together. So the next is few type of specific type of vectors. So one by one I will come into that. The first one of type is the equal vector. Now a vector, if two vectors are such that they are equal in magnitude, and direction, then they must be said to be equal vectors. But because vector is only consists of magnitude and direction, so if magnitude and direction are same, then only you can say, because there are no other characteristic. But if I say like that, if I say that 2 Newton east, this is a vector whose magnitude is this one and direction is this one. If it is compared with another vector which is 2 meter per second east, can it be compared? Because the magnitude is 2 here and the direction is also same, but the thing is different is the unit. Here the unit is different but both are vector, both having same magnitude. That both can be represented with the arrow with the head. This one, this is also an arrow with the head. This one. So both cases the value, magnitude, and directions are same, but their units are different. So two equal vectors, the vectors to be equal, you can say it like that, or two equal vectors have to be matched equally by their magnitude, direction, and unit. So this is very crucial point to understand. So two different or distinguished vector means differently defined vectors cannot be added by any law of vectors, whether they are linear in nature or any other angle they are found. They cannot be added unless and until their means for adding there no need of having equal numeric, but for means for defining or saying it, those vectors are equal. Not only the magnitude and direction has to be matched, their unit has to be matched. So this is the condition of equal vectors. Next come your negative vectors. Negative vector. So negative vector is those whose magnitude are same, but they are opposite in direction. You can say two parallel vectors which are of same magnitude but different in directions. So difference in direction means their directions is 180 degree apart. So those vectors whose magnitude is same and direction is opposite, those are called negative vectors. In that case, if it is A vector, so that opposite of equal vector can be represented as minus A. Or if I represent it as B vector, so we can write vector A is equal to minus of vector B. Okay. It must be the opposite vectors and the magnitude is same. But we cannot write vector A equals to vector B. It is wrong because direction defines their vector is defined not only by the magnitude, the direction. That has to be remembered throughout your study. So negative vectors are those are equal in magnitude but different in direction. That different direction is 180 degree apart. So then only we will call the negative vectors. Another pattern is called parallel and anti-parallel vectors. These vectors are, their magnitude may not be equal, but their direction are same. For parallel vectors, so these are parallel if directions are same but magnitude are not same. Because if magnitude are same, they falls into single category, that is equal vectors. So except equal vectors, all parallel vectors are having different magnitude, you can say. So parallel vectors are those are, and anti-parallel are those are different in direction, means magnitude and directions are different. Magnitude are not also matching, and direction also 180 degree apart, anti-parallel. Okay, so these are called, so this also called, this also named as like vector, and this is also called unlike vector. So these are named by parallel and anti-parallel, or like are unlike vectors. Okay. The another one is collinear vector, where two vectors, if I draw and if I extend it, they are falls in same line. So they are falls in same line if it is extended. Okay, so the both vectors, they are falls in same lines, and then these are called collinear vectors. Similarly, coplanar vectors are those which are lying in same plane. Same plane means it is formed by two dimensional. It is, if we say x, this is y. So in that, any vector lies any direction. So these are all coplanar vectors. So we can say any two vectors, if I consider in any plane, if two vectors only is there, so with a two vector we can make a plane. So two vectors always form are lying in a plane if it is two vectors. Just like two dots can form a line, so two vectors always lying in a plane, whether you keep it is side by side or one above after. So if I cut those vectors, that will be a single plane, whichever way you consider. But if it is more than two vectors, then we cannot say that they can lie in same plane. Definitely there may be that two line and other is not. There may be that two plane, they are lying on three different plane if I combine it. So this kind of system also I have read, also I have discussed, that is a Cartesian coordinate system. Here three the coordinate axes are mutually perpendicular to each other, and the same way the plane formed by the two axes are mutually perpendicular to each other. So in that case, if more than two vectors, we cannot say that they are lying in a same plane. They may lie on different plane, or apart from this, there may be any other plane they may lie. Okay, so these are the called non-coplanar vectors. Okay, so then after coming concurrent vectors, concurrent vectors. Okay, in that case, vectors, two or more vectors, if they are physically intersecting each other at a single point, or their line of action, that means three vectors are not physically intersecting, rather they are acting such a way, if I extend it, or if I say, if I extend it, actual vectors is this one and this one, and another one is this one. If I extend it, they merge a single point, then also these vectors are called concurrent vectors. So their actual point of contact, they are actually concurrent, actually cutting each other at a single point, or their line of actions. This means if it is extended, line of actions match is merging into a single point, then also they are called the concurrent vectors. Next comes the unit vectors. Unit vectors. So unit vector is the vector which is the which when multiplied by with any numeric quantity will turn it into a vector. That means this is a vector. So this has a magnitude. The magnitude only represented by any numerical value, let's say n, and if it is multiplied by a unit vector, let's say I am writing it unit vector, it will turn into a vector, let's say a. So this is numeric, this is scalar. This multiplied by the unit vector will become a complete vector. So how the unit vector is denoted? The unit vector is specifically denoted by let's say a cap. So a cap, if I assume it is a unit vector along this vector, so this can be calculated by vector a as a whole, and the numeric value of it means the mod of vector a. If I do that, then I will get a unit vector along the a axis, means a direction. So the a cap is the unit vector along a. So the unit vector, if I take the mod of it, it always be 1. So any unit vector, if I take the value, it will give the value always equal to 1. So in Cartesian system, there are three axes, x, y and z. In x direction, we assume the unit vector is by I cap. In y direction, it is denoted by j cap, and z direction it is k cap. Okay, so if I represent any point P with the coordinate x, y, z, then the vector which will be with reference to a fixed point, let's say origin O 0 0 0, this vector is called the position vector, and this position vector OP, the position vector which is represented by the point P with reference to the fixed point O with the coordinate of x, y, z, that OP vector will be represented by x I. X is the numerical value. If I drop it there, the x value, so this will be your x value, this will be your z value, this is your y value. Or if I turn it, okay, for a better understanding, I'm just writing it like that. So x this way, y this way, and z. So I'm reaching there. This is x, this is y, this is z. So that OP vector can be represented by y, j plus z and k. So this is the position vector due to the point P with reference to a Cartesian system will be represented as this. Or if I consider the two-axis system x and y, and any vector p, which is again a position vector OP. So OP here only two part will come, xi plus yj. So this is the position vector, or any vector you can say will be represent generalized form this way. Okay, so unit vector is the vector which is the vector divided by the mod value of that vector, can be calculated like with that, and any mod value of unit vector is always equal to 1. Okay. I also told you about the dot and cross product. One more thing you have to understand, that I into I dot product will give you 0. It will give you 1, because I dot I, if I is a vector, this I also a vector. If I and I dot vector, we know that the mod of I and along with the cos theta. Now you see, if in x direction any unit vector and unit vector in between the angle theta will be 0 degree, so the cos 0 is equal to 1, and unit vector mod value of unit vector we know 1, so 1 into 1, and the cos is equal to 1, is all will give you 1. So any unit vector along any axis, any direction, if I multiply with the dot product, it will give you 1. Okay, and similarly, if I multiply any other unit vector mutually with other one, so this will become I into, let's say, this will be considered as a cross product. That will not be a dot product, because the direction of I and is 90, and their movement will be on the this axis. So this will always be a cross product into mod of k. Okay, into mod of k into, in this case it will be sin theta. Now I have to consider dot products, because if two position vectors to be calculated by matrix method, this is useful. So just for the sake of understanding, when I will do the dot product of two unit vectors, so as because the angle between this is 90 degree, so this I into k, the unit vector mod value, into cos of theta. Here cos of theta is equal to cos 90, so cos 90 is equal to 0, so ultimately the value becomes 0. So if similar vectors are multiplied, unit vectors, then we will get 1. If dissimilar, or you can say the axis which are mutually perpendicular, along that axis any unit vectors are being done dot product, the value will become 0. So this will be useful when you use the matrix method to solve any position vectors. Not now, but this is not needed now, that will be taught in higher classes. Now I am just going through the basics which will be needed for study of kinematics. So this is unit vector. Then comes the null vector. Then comes the null vector. Null vector is that whose magnitude is 0. Magnitude is 0. But this also will get by cross multiplying two vectors. Okay, so when we do the cross multiplication of vectors, if the result becomes 0, so that means 0 itself, because I can eliminate the value, because 0 will come by multiplying the numeric values. So one of this can be equal to 0 mod value, then they turn it to a 0. But direction cannot be eliminated, because the direction, the result it would follow, if it is not 0, the direction could be something. So if it is 0, then only numeric value will be 0, but it will represent a vector. This must have some direction. So null vector, the magnitude is 0, but the direction is not undefined. That direction could be anything, because if I draw a dot, that means their value is 0. So that dot may have any direction, could be its direction. So null vector is always having some direction, but that is not defined, that is undefined. It could be of any direction. For unit vector, it is definite have a direction, but null vector, it could be any direction, but definitely have some direction, but undefined. Okay. This will be very much clear when we may study in higher classes the dot and cross product of that, but it is enough right now. Next come the scalar. As we know, it follows, scalar follows commutative, follows commutative law. Commutative law is that in numeric problems we might have come across that if two numbers a plus b can be written as b plus a, that means if 2 plus 3 is 5, then 3 plus 2 also become 5. So a plus b is equal to b plus a. This can be written in scalar, but whether it can be written in vector also, that means if it has to be written in vector a plus b, then if it is commutative, then we must write b plus a. So how will we do that? If say two vectors are arranged head to tail to head, and then another vector following from tail to head. Two vectors are cumulatively acting, so we have to find the resultant or the sum of these two vectors. So the sum of these two vectors, let's say this is displacement 5 meter, this is let's say 6 meter, this is displacement along some path. Now the ultimate displacement we have to consider. So this has moved, this is changes direction. So ultimate is the tail to head. If I add, so this will be the resultant displacement. Now if r we get by the vector 5 meter and vector 6 meter, then again now what I have to do? Now we have to get 6 followed by 5. Now 6 is followed by 5, so 5 is coming first, then 6. Now to get 6 mm vector first, then followed by 5 mm, so we have to change the position. That means this head has to be attached to the tail. Now if I take any vector parallel to this, because parallel vectors, the parallel shifting of vector does not change the value, so this 6 vector can be written like that. Now, and if this is written parallel to this, so then this vector also, now you can see that arrow for this 6 vector which is taken parallel to this is this way, and followed by the 5 will be this. So 5 here 5, so this does not change its value as it is parallelly shift. This also parallelly shift. Now you see for this case 6 and 5 are coming consecutively after following 6, 5 is coming. So their resultant if I want to get, so then tail to head I have to add. Now if this parallel to this parallel to this is a parallelogram, and their diagonal, if I follow from any diagonal which is uh, the result of the uh, two arms, the two corners being added. So if this is r representing the sum of this, so this also represent the sum of this and this, because this is common diagonal. So you can say if r is equal to r, then 5 plus 5 meter plus 6 meter, the value will be same as 6 meter plus 5 meter. So then vector, you can say, follows the commutative law. Okay, this will be very useful while we'll do some more addition rules for vectors. But now I will not continue on that. Better after that I will move to the kinematics, because that much details is not required in kinematics. Only thing is that what is exactly the scalar and vector, that understanding is needed, and how they are related. Okay, so this is for the class. Now in the next I will move to the kinematic theory straightway, depending on these subjects that I have discussed. Okay, so thank you for now. Please wait for me for the next classes. Thank you.